To understand this topic, you need to know about what the UPAC and what does it do. The UPAC is the International Union of Pure and Applied Chemistry. It's an international scientific organization not affiliated with any government. The UPAC studies advanced chemistry in part by setting global standards for names, symbols, and units. Our purpose is that you learn about organic chemistry. Come on, you will learn with us. For name hydrocarbons, it's important to memorize a few basic names. In general, the base part of the name reflects the number of carbons in what you have assignment to be the parent chain. The suffix of the name reflects the type or functional group present on a parent chain. Other groups which are attached to the parent chain are called substituents. Some common hydrocarbons are ethane, methane, cyclopropane, propane, methylpropane, butane, methylcyclopropane, cyclobutane, methylbutane, pentane, cyclopentane, dimethylpropane, cyclohexane, hexane, cycloheptane, heptane. A hydrocarbon is an organic compound made of nothing more than carbon and hydrogen. It is possible for double or triple bonds to form between carbons and even for a structure such as rings to form. In the classification, saturated hydrocarbons are alkanes, are the symbol of the hydrocarbon species. They are composed entirely of single bonds and are saturated with hydrogen. The general formula for saturated hydrocarbon is CnH2n plus 2. Unsaturated hydrocarbons have one or more double or triple bonds between carbon atoms. Those with double bonds are called alkenes. The formula is CnH2n. Those containing triple bonds are called alkynes, with general formula CnH2n-2. Cycloalkynes are hydrocarbons containing one or more carbon rings to which hydrogen atoms are attached. The general formula for saturated hydrocarbons containing one ring is CnH2n. Aromatic hydrocarbons are also known as arenes. Are hydrocarbons that have at least one aromatic ring. Aromatic hydrocarbons are also known as arenes. Are hydrocarbons that are at least one aromatic ring. UPAC rules to name alkanes. Step 1. Count the number of carbon atoms in the long continuous chain, the parent chain of the structure. Step 2. Number each carbon in the parent chain. Locate the end carbon closest to a substituent group. Give all the substituent groups at the lowest position number possible. Step 2. Name each alkyl group substituent. Place the name of the group before the name of the parent chain. Step 4. If the same alkyl group occurs more than once of the branch of the parent structure, use a prefix D, 3, tetra, and so on before the name to indicate how many times it appears. Then use the number of the carbon to which it is attached to indicate the position. Step 5. When different alkyl groups are attached to the same parent structure, place their name in alphabetical order. Do not consider the prefix D, 3, and so on when determining alphabetical order. Step 6. We enter name using sequence to separate numbers from the words and commands to separate numbers.
The tips on how to draw structural formulas for alkanes. First step. Identify the data of the formula that you are given. Second step. Write the longest carbon chain. Third step. Place the radical on the chain. Fourth step. Complete the structure to complete the 4 hydrogens on each carbon bonds. With the above steps, we will take a sample which is as follows. The formula is 2,2,4 trimethyl pentane. The first step is to complete the carbon chain. After we situate the radicals, and the third and final step is to complete the structure to complete the 4 hydrogens carbon bonds.
Hello, I'm going to talk about how to name alkenes. Well, first, alkenes are open chain hydrocarbons which are characterized by having one or more double bonds. They are named as alkenes, but with termination in. In this case, we have this compound. And the first step is choosing as the longest main chain containing the double bond. And in this compound, the longest chain is this. And well, having branches, it is taken as the main chain containing the largest number of double bonds, but is shorter than the other. The second step, it is to counting from the closest end to a double bond. The hydrocarbon is named by specifying the first carbon containing the double bond. But in this case, we number it from the number 1 to the number 9. And the double bond is found in the number 4 that is in here. And now we name it alkyl groups and sort them alphabetically. And in this case, we have ethyl, methyl, and other methyl. And some unsaturated hydrocarbons contain more than one double or triple bond. The number of double bonds in short molecules is shown by using a prefix D, tri, tetra, and so on before the suffix in. In this case, the name of this compound will be 3-ethyl 2,7 dimethyl 4-nonene. 3-ethyl because in the side is found the ethyl, and 2 and 7 dimethyl because there are two over 1 and 2 methyl, and 4-nonene because the double bond is found in the number 4, and nonene because the longest chain has 9 carbons. And well, that's it. Hello, I'm going to talk now about how to name alkynes. Alkynes are open chain hydrocarbons with a characteristic of having one or more triple bonds. Follow the guidelines given to alkenes, but ending in ion. Well, the first step is backbone is chosen as the longest containing triple bond. The numbering must give the smallest particles to the triple bond. In this case, we have this compound. And well, we need to choose the longest containing triple bond, that is this. And the backbone is the one with the largest number of unsaturations, either that is double or triple bond, but blocking locators are the lowest numbers possible. And then we numberate the longest chain, the carbons, from the 1 to the 5 to the number 5. And in this case, here are 5 carbons. And carbons numerated starting with the closest and having an unsaturation. It's say a triple bond. Name the row locators, radical names in alphabetical order. Finally, name the main chain with the corresponding prefix and terminal "-ane". And in this case, the name of this compound will be 4-methyl 2-pentane. And that's it. Well, now I'm going to talk about aromatics. Aromatics are hydrocarbons derived from benzene. Benzene is characterized by unusual stability, which is given to by the particular arrangement of conjugated double bonds. When the benzene radical is followed by the word benzene. In this case we have two examples for aromatics, but first we will see the first one. And well, in this case, the first one example has only one radical. That is this, and for that the aromatic is called nitrobenzene. Well, the second one example say if are two radicals, they are indicated throughout the numbers 1, 2, 1, 3, or 1, 4 places. In these cases, it uses the prefixes ortho for 1, 2, meta for 1, 3, and para for 1, 4, for indicate those positions in the second substance. In this case, we have two radicals that are methyl, and this case is a special case because this has two names. The first one name is 1, 2, and dimethyl because the radicals are methyls and they are in the number 1 and 2, and the word benzene. And the second name is O for ortho, that is for the numbers 1 and 2, and dimethyl because they are methyl, and the word benzene. And well, that's it. Well, now I'm going to talk about how to draw a structural formula for alkenes. Right. First, we have this name 2 for dimethyl and 2 benzene. Well, the first step is write the longest chain of carbons in this case, and is 5 carbons. One, two, three, four, 5, and then place the double bond in the carbon in the case allocator 2, and in this case is this is a double bond in the second place, and the number 2. And the next step is radical locator on the chain with the help of the locators. And here are the radicals, here and here, the 2 and 4, and finish this complete carbon skeleton with hydrogen to complete the 4 bonds of each carbon. And the complete skeleton will be this. And because this is 2 for dimethyl, because there are 2 methyl, and 2 xanthan because, and the number 2 are the double bond, and xanthan because are the longest chain and there are 5 carbons. And well, that's it. Well, now I'm going to talk about how to draw a structural formula for alkanes. Well, In this case, we had this name: 3-propyl 1,4-pentadiene. Well, the first step is write the longest chain of carbons. In this case, is 5 carbons. And this 1, 2, 3, 4, 5. And the next step is place the trouble bonds in the carbon that indicate locators. In this case is this one. This will be the number 1 and the number 4. And then is radical locator and the chain with the help of the locators. And in this case this is the radical in the number 3. And finally, complete carbon skeleton with hydrogen to complete the 4 bonds of each carbon. And the complete skeleton is this. And of this way we had the structural formula for the 3-propyl 1,4-pentadiene, because it's 3-propyl, 3 because it's located in the number 3, and this radical is a propyl, and 1 and 4 are the triple bonds. Well, that's it. Thanks. Well, now I'm going to talk about how to draw a structural formula for aromatics. And well, first we have this name: 1-ethyl 2,4,5,3-methyl benzene. And well, the first step is place the locators on the carbons of benzene. And it's something like that. We have the carbons, and the next step is locator on the corresponding radical carbons. And we located this, and 1, 2, 3, 4, 5, and finally complete the formula with hydrogen atoms. It's something like that. And this is 1-ethyl, because in the number 1 there is ethyl, and 2, 4, and 5 3-methyl, because there are methyl, and the word benzene. And so it's like we complete the structural formula. Thanks.
Hello, I am going to talk about hydrocarbons derivatives. Hydrocarbons are the simplest organic compounds, contain only carbon and hydrogen, which may be straight chains, branched chains, or cyclic molecules. Carbons tend to form 4 bonds in a tetrahedral geometry. Hydrocarbon derivatives are formed when there is a substitution of a functional group in one or more of these